For sure. All right, so we have one more minute. The next speaker we have, MD Isaac, he's also a streamer himself. He's also a good friend of mine. He does a lot of hacking live also. I think he does, I think his audience is mostly Turkish, but this talk is special because not only he is a great hacker, he's a streamer and also a first-time speaker for anything that we have organized as this group. He wasn't at VersaCon, and he also he's just here for the first time. So before we get started, can we get the chat a little bit hyped up? Drop some MDISec emotes if you are a subscriber to his channel, and if not, drop some other emotes. Let's get this chat hyped up, and we're going to bring on his talk in a few seconds.
Let's talk about finding a zero-day vulnerability on the security solutions. This is Mehmet İnce, and I've been working as a vulnerability researcher since 2005. You can find me on Twitter with an MDISecHandler, and the pentest.blog is a web page where me and my teammates writing technical articles about our research. Today's case study is Trend Macro Interscan Web Security Virtual Appliance. We are going to talk about the combination of the different vulnerabilities that I found on the product, which gives us a remote unauthenticated code execution with a root user. So here's the methodology of my vulnerability research project, and the first step is quite easy. Find a way to get a free trial of the product and read the documentation about it, and find a way to make a SSH connection to the box. Try to understand the features, enumerate all the service and the configuration, and the most important part is that define the attack vector and find the vulnerability. Free trial step. It was quite easy in that case, but it's not always easy to get an access to free trial. Sometimes it requires to lots of meeting with the sales team, but in that case it was quite easy. And the second step is reading the manual and the information about the product. You have to get as much as possible information about your target, because you will use those information during the exploitation phase. And as you can see in here, we are seeing the different mode selections about the product. It can be installed as a breach mode, forward proxy, reverse proxy, etc., etc. You can even see the graphic and the detailed information about the mode selections in the documentation. So it is quite important to get those information before doing something technical. And the third step is we have to find a way to SSH to the box. Since we are installing the product in our environment and it's been shipped as an ISO file by the vendor, you can set the administrator password during the installation, but when you do the SSH connection, it will gives you the restricted shell, and there is nothing you can do too much about thing in the restricted shell. So we have to find a way to get rid of those restricted shell, and we need to have a remote SSH root shell in our environment. It is quite important because you want to do remote debugging, you want to have access to the code base in the product, you want to enumerate the different services, and in order to do all those stuff, you have to have a SSH connection. So in that case, the operating system has a lot of hardening. So you have to install the ISO file into your virtualization system, of course. And if you when you do that, you can detach the VM disk from the virtual machine. You can attach it to the different Linux machine. And when you do that, you need to mount the new disk and find the grab file, because there was a grab protection in the box. So you can simply remove the protection line from the graph file, and then you can go to the SSHD config file in order to enable remote root login. And as a final step, you can edit the passwd file, and you can give the bin bash for the root user. And you can mount the disk from your secondary virtual machine. You can attach the VM file, and you can attach it back to the original VM, and you can reboot, you can restart the operating system, and you will be having a remote SSH connection to the box. Those kind of things are important before doing vulnerability research project. And the fourth step is it is quite important to understand the feature of the product. Just install it into your research environment. Try to use the product in a normal way, I must say. And since we are going to talk about the reverse proxy installation of the product, and you can go to the administrator interface of the product, which is quite easy to use it because it's a solution, as you know. It doesn't have, sometimes it has a beautiful UI user interface, but you need to get familiar with the features of the administrator interface to find out how these things is working. The fifth step is quite important. We need to do enumeration of the bugs. There you can just get the output of the nestat command to find out what kind of services are running in the box. As you can see in the red squares, there was a UWSGI service, which means most probably there's a Python project running on a port 6011, and there is a Java services which is listening to administrator interface port. That means the administrator interface is written with Java, and most probably it's being run by the Apache Tomcat service. And there is IWSSD which listens to port 8080 and 8081. That is the service is running for the reverse proxy itself. So since the product is a reverse proxy, that means it's being placed between the client and the user, and that is a specific process which is responsible for the taking the request from the user and send it to the requested source. And we have to do enumeration. We have to keep doing the service enumeration. We get the information about what kind of service we have in here, but you need to find out which are those services are accessible from the outside of the box. You can use the IP tables, or you can just run an nmap scan from outside of the box to find out which are those services are accessible from the outcoming connections. All right, let's have a look at the Python process that we have seen earlier. As you can see, there is an Apache SOLR service and lots of Python services. That means there is a internal Python project, and it's most probably responsible for parsing the log files and the querying. So most probably whenever you try to query something through the administrator interface, that data can be parsed by that Python project, or it can be delivered by the Python project. But the important thing is that we have the Apache SOLR service in here. All right. Let's have a look at the ISW SSD service. You can find the full path just by grabbing the process tree, and you can use the file command to find out what is the file type, which has the symbolic link to the ISWSS-process, which is a Linux binary, and it has more than it actually specifically has 61 imported projects. So basically, it's a very huge binary file, and I can tell you it is written with the C++. So we are facing with a different type of technologies. We have the Apache SOLR, Python project, Java for the administrator interface, C++ project for the reverse proxy service. So those are the important information about our target. So we got enough information, I believe, about the product, so we can define some sort of possible attack vector. So we know that this product is being placed between the client and the destination. It takes the request from the client and it sends it to the destination on behalf of a user. And whenever the proxy gets the response, it forwards it back to the client. So that product also is capable to offloading the SSL, parse all the HTML content, scan the files, because this is a web security solution. It tries to understand what's happening on the client's network. So it has to see all the files, parse the HTML content, offloading the SSL, etc., etc. So that is another attack vector we can aim. In the third step, you can see the administrator interface is written with Java. So we can basically just focus on the administrator interface to find out something important. And also we can target the proxy service, which was written with C++. And as you know, there's a lot of internal services, but most of them are not accessible from outside of the box. So those are the possible attack vectors where we can target from outside of the box itself. Let's start with talking about the administrator interface. Whenever I'm dealing with the Java project, I'm start doing the configuration understanding. I'm just reading the configuration file as the initial step to find out the initial information about the project itself. But we don't have a direct source code access. We have all the jar files in the box, and thanks to the operating system hardening breaking stuff, we can secure copy all of those jar files and the configuration files into our main host to do further analysis. So if you have the lots of jar files on your hands, I strongly suggest you to use IDEs, because IDEs gives you ability to find out the function definition just by clicking on a function. And also you can find a different location where the specific function you are interested has been called. I used to use GDGUI for that purpose, but since that project has a lot of libraries, because there's a lot of third-party Java libraries, and you want to have the click and continue the function definition feature. And if you put lots of heavy work onto the GDGUI, it wasn't just working as expected. So I just shifted to using IntelliJ or the Eclipse for that purpose, and you can decompile all the jar files and you can put them into the IntelliJ project as a library, source and classes, and the IntelliJ will do the rest of the job you want. So it's going to process and analyze all the source code, and it will give you a quite easy way to find a function definition and everything. So far, we got all the information, at least for the initial step, all the information we need. We have an access to source code of the administrator interface. So it's time to start reading some source code. So you can either go to top to bottom or bottom to top. So bottom to top means, let's say you know the potential vulnerable functions, and you can directly search those functions in the code base. And if you believe you find some sweet spot, you can try to find out you can reach those code path or not. So you are starting from bottom, right? And for the top to bottom, you can start by reading filters or the middleware layer of the project. You can go to the request handler or the controller layer, and you can go to the repository and the rest of the thing. So in that case, I was kind of doing top to bottom approach. So I was reading the handler functions, and then after spending a couple of hours on the code base, I found that particular function definition. And it is accessible by /mount_ device path, and it takes the post request. And if you look at the initial definition in the code base, it tells you if the request is not coming from the localhost, I'm going to validate this request. So if you manage to pass that if statement, it calls to get token. And if you look at the rest of the function definition, there is something different, something special is happening. So it takes the post body and it parses as a JSON object. It does some escaping stuff, especially have a look at the for the line 418. So it escapes the $sign within a backslash, and after 2 lines later, it escapes backslash one more time. So there is a double escaping on backslash character. So if you keep reading the code base, as you can see, it passed those parameters to the exe_UI helper CMD function, and the name of the function explains itself. Keep reading the source code, because we are interested in that particular function, exe_UI helper CMD. And as you can understand so far, after param variable has been passed to that function, and we can control everything in after param. And there is some sort of escaping happening in there, and there is a problem because the backslash is escaped twice. It executes the UI helper binary, which is located under the etc icon admin UI folder. And if you look at that binary, it has the SUID bit, and the owner of that binary is root. So that means that request will be executed with a root user privilege. And finally, we are seeing the execmd function. And execmd function basically executes the command has been given to the function. So we have remote command injection vulnerability, but there is a limitation. Authentication is required to exploit that vulnerability. We have two options here. We have to find a way to authentication bypass, or we need to find a way to some sort of SSRF vulnerability to reach out that specific endpoint from the localhost, because as you can remember, the requests coming from the localhost are allowed in here. Okay, so you might remember get token function from the previous slides. Basically, it takes the cookie of the request and it prints out that cookie name and the value. But the problem is those printing out thing is going to be written into the log file on Tomcat project. So if you find a way to local file disclosure, we can directly go and read the content of the Apache log file, and we can extract the valid session ID. So we don't need to necessarily have a way to bypass authentication. We just need to find a local file disclosure, right? So in order to find a local file disclosure, or I was thinking about targeting the proxy service itself, because it just takes the URL you want to visit from the user. As you can see in this picture, we are communicating with the proxy service, and we are telling them that, all right, I want to go to the pentest.blog, and the proxy service sends that request on behalf of you, and you will get the response when the proxy service gets the response from the destination. So this is basically how it's work. Of course, it is much more than this, but this is the basic understanding of the proxy service. What happens if I tell the proxy service that, okay, I want you to communicate with yourself? And when I tried that, the proxy service told me that self-referential requests to the proxy are forbidden. So that was interesting. If I find a way to trick the proxy service to communicate with himself, I may find a way to communicate with the internal services that we talked previous slides. So I just want to see how this error is being produced by the proxy service. So I just breakpoint into the get end user order notification function, which is producing exactly same HTTP response we are seeing in here. And that function, when I hit the repeat button on the Burp Suite Pro, I see the function calls, because that notification function is being called by the Prepare proxy loop rejection, and it is being called by the handle proxy, and which has been called by the do processing. So let's start doing some easy reverse engineering stuff on the do proxy function definition. As you can see, it was a very huge file, but very specific portion of the definition of the do processing function. It just looks for the configuration file by doing is reverse proxy function call. So basically, it's trying to understand, am I placed as a reverse proxy? And in that case, it calls the handle proxy loop, and the proxy loop calls is same address function from the TM Circuit address class, and that particular function spatially compare itself with the target destination by doing full URL comparison. All right. So, and if those two addresses are same, it calls the prepare proxy loop rejection. So I just told him, all right, I want to communicate with the different port on your localhost, because you are being installed in a port 8080. All right, I'm telling you the same IP address, but I'm telling you the different port. And there is an Apache SOLR service in the local service that we have seen previous slides. So in that case, that proxy service get me to the answer. So I have an access to SOLR administrator interface that runs in the box as a local service. So that was another vulnerability. And as you can see, the vulnerability description provided by the Zero-Day Initiative company, they told that an attacker can leverage this vulnerability to bypass authentication on the system. I believe everyone right now understands what's happening. So after that point, I started to working on the Apache SOLR service, and unfortunately, there was a very old version in the box. It's not quite easy to upgrade your third-party services like a database on the SOLR if you are doing those type of products. So there was a very old and known vulnerability, which is the arbitrary file read via path traversal attack. So there was a vulnerability in Apache SOLR service, and I find a way to communicate with Apache SOLR service itself. And by using known vulnerability in the Apache SOLR version 4, I managed to get in the content of the NO file I want. So as you know, I just changed the file from etc path reader to the tomcat catalina.out file, and I have seen that the session ID is. So the developer just innocently decided to print out the cookies during the parse of the cookie header within the getToken function, and that information is written in the log file. And by using the two different vulnerability together, we managed to leak the active session IDs. So exploitation chain is quite easy actually. We're gonna exploit the proxy service vulnerability itself. We're gonna force him to communicate with a SOLR service that is running on the box itself. And when we do that, we can exploit the old vulnerability in the SOLR service to get a content of the catalina.out file. And we need to find a session ID thanks to the getToken function definition, and we can go back to the exploitation of the command execution vulnerability, which requires a valid authentication. And combining all of those vulnerabilities, we got your remote root shell. Here is the Metasploit module that I implemented for that vulnerability, and it is quite easy. You are just telling okay, this is a local host, this is the remote host, and get my shell and run. There you go. You got the remote unauthenticated code execution with a root privilege. And there you go. This is how I find the zero-day vulnerability in the security solution, guys. Thank you very much for listening. And if you have any questions, you can follow me on Twitter. Thank you very much, guys. Thanks.